Today we're going to look at rational exponents. First of all, we have radical notation to rewrite each expression. 36 to the 1/2 is the same as the square root of 36, which we know is 6. 27 to the 1/3 means the cubic root of 27, and we know 3 times 3 times 3 is 27, so the cube root of 27 is 3. The quantity 3x raised to the 1/5 is simply the fifth root of 3x. 16 to the 1/2 again is the square root of 16, which we know is 4, and that negative's hanging around out front, so we find an answer of a -4. 6 times y to the 1/3 power. Y is the only thing that has the cubic root. 6 is out there as a coefficient, so we have 6 times the cube root of y. Use radical notation to rewrite each expression and simplify if possible. So we have 9 to the 3/2, which we can write as the square root of 9 cubed. We know the square root of 9 is 3, so we have 3 cubed, which is 27. 216 to the 2/3, well, we know the cubic root of 216 is 6, and that's squared, so 6 squared simply becomes 36. We have a negative out front of this 64 raised to the 2/3. Well, we know the cubic root of 64 is 4, and we still have that negative out front, and we have to square the 4, so we get 16 times that negative, or -16. We have 7x minus 1, that quantity raised to the 3/5. Again, the denominator is the root, so we have the fifth root of the quantity 7x minus 1 cubed. Rewriting each expression with a positive exponent, I want you to think of this 25 raised to the -3/2 as 25 to the 3/2. That negative does not make it a negative number, but simply puts it under 1. Well, we know 25 to the 1/2 is the square root of 25, so that cubed is the same as 25 raised to the 3/2. Well, the square root of 25 is 5, and 5 cubed is 125. We still have that 1 hanging around on top for our numerator, so our answer ends up being 1 divided by 125. We have 64 raised to the -2/3. Again, that negative does not make it a negative answer, but simply puts it under 1. The cube root of 64 is 4, and that is squared. Well, 4 squared is simply 4 times 4, which is 16. We still have that 1 hanging around on top for numerator, so our answer is 1 divided by 16. Use the properties of exponents to simplify. So we have x to the 1/2 times x to the 1/8. We add those exponents. Well, we know 1/2 is the same as 4/8. So 4/8 plus 1/8 is x to the 5/8. When something is divided, we bring the exponent up. We subtract the exponent. So now we have 5 to the 1/2 minus 3/2, and we find that's 5 to the -1. 5 to the first is 5, and again, that negative puts it under 1, so our answer is simply 1/5. We have 3 to the 3/8, the whole quantity to the 4th. Then we multiply that 3/8 times 4, and we get 3 to the 12/8, which if we take 4 into both of those, we find that it's 3 raised to the 3/2. Using rational exponents to simplify, we can write this as x to the 10 over 20, and you can see those zeros go away, and we get x to the 1/2, which we know can be written as the square root of x. Then we're asked to do the 4th root of 16. Well, that can be written as 16 to the 4th, and we know 16 is 4 squared, which is 4 to the 2/4, which reduced is 4 to the 1/2. which is the square root of 4, or simply 2. Now on this one, if you could remember that 2 times 2 times 2 is 16, you would automatically know that our answer is 2. Use the radical exponents to write as a single radical expression. We have the square root of z times the fourth root of z, which is z to the 1/2 times z to the 1/4. And again, z to the 1/2 can be written as to the 2/4. We add exponents and we have z to the 3/4. Writing it as a single radical expression, we know the denominator is the root. So we have the fourth root of z cubed for an answer. We have the square root of 1 times the cube root of 3. Well, the square root of 1 is simply 1, and 1 times the cube root of 3 is the cube root of 3.